Good morning, guys. This is part 2 of your Gravity Notes lecture. Again, I'll tell you what you need to write down, but make sure you watch this video and maybe even watch it a couple times so that you can really get this information. And then, of course, you can always rewatch this video when you do your quiz, which will be coming probably next week. So make sure you take time to watch these. Last time we ended on this question, we were talking about falling objects. And from our lab, we learned that if you have two objects and if you can ignore air resistance, if you can get rid of the air, so there's no air resistance keeping the thing floating up, objects will fall at the same speed. If you're on the moon, a hammer and a feather or a bowling ball and a feather would fall at the exact same time. Or if you're in a vacuum chamber, we saw that in the video last week. Get rid of the air and things will fall at the same speed. If gravity is constant, then two objects will fall at the same speed if you can get rid of the air resistance. We mentioned that if you take an object and you drop it, it's going to go faster and faster and faster and faster as it falls. It accelerates. And again, that's because the forces on that object are unbalanced. If you remember when we talked about unbalanced forces, here's the object that's falling. Gravity's pulling it down. And to begin with, air resistance is very light. And so it's unbalanced. And so it speeds up as it falls. It goes faster and faster and faster. So here's the question I posed you at the end of last time, and I wanted you to think about this a little bit. So if you're on the top of this tall building and you throw a penny off, it's going to fall. It's going to go faster, 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 faster as it falls. You're really high up in the air on this building, and so it has a lot of time to speed up. So the question is, would it get as fast as a bullet, hit somebody on the head, and just kill them like a bullet would? Well, you have to think that as that object falls, there are two forces acting on it. There's gravity, and then there's the air resistance as well. And as the object falls, as it goes faster, the air resistance gets stronger. So to start, the gravity is really strong and air resistance is really weak. And so it's accelerating. It's going faster and faster because it's unbalanced. But as it falls, that air resistance increases, and then it goes faster and the air resistance increases. You can see here it's called drag, which is the same thing as air resistance, until at some point the air resistance balances the force of gravity. So yeah, it speeds up, but the air resistance increases until they're balanced. Now, if forces are balanced, the net force is zero. The overall force is zero. Well, it's still moving, it's falling. But this means it's not speeding up anymore. It has reached its maximum speed. It speeds up until the air resistance matches the gravity, and then it just keeps that speed the rest of the way down. Now, this is something called terminal velocity. It's the fastest speed that an object will fall when the air resistance balances out the gravity. It's going to be different for different objects. A bullet is going to be able to go much faster than something like a penny or a piece of paper because of the air resistance. But this is called terminal velocity. Make sure you write this down in your notes. You can do it from the video by pausing, or you can go to the slides that I have in Google Classroom. But terminal velocity is the fastest speed an object will fall when the air resistance balances out gravity. So back to our question. You throw the penny off, penny goes faster, 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 but at some point it reaches terminal velocity and it doesn't speed up anymore. So it's not going to get as fast as a bullet. Now, it would hit somebody on the head and it would hurt. It'd probably do some damage to their skull, maybe even crack their skull just a little bit, or at least give them a pretty big bruise, maybe a goose egg. But you're probably not going to kill someone. It's not going to get as fast as a bullet. It's not aerodynamic enough. It doesn't cut through the air quite well enough for that to happen. And that's because of the air resistance. Okay, so what if you do this again, but this time you do it without air? Theoretically, right? There's no air now, no air resistance, so there's no upward force. Now, would it get as fast as a bullet? Yeah. If there's no force counteracting it and gravity is the only thing pulling on it, then yeah, it's going to go faster and faster and faster and faster until it hits the ground or the person standing under there. And yeah, it's going to get as fast as a bullet and it would kill him. So fortunately, that air resistance keeps that from happening because the penny isn't aerodynamic. Well, I remember reading a news article a while back, down at the border between Mexico and the United States, in like Texas and Arizona. There's sort of a tradition where at New Year's Eve, they'll take their guns and they'll boom, 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 they'll shoot their guns up into the air. Those bullets, of course, go very high, as high as a building. Then they stop, and then they fall back down. Now, a bullet is aerodynamic. And so it is able to get back up to a high speed where there have been people, unfortunately, who have died from that. People shooting their bullets up in the air, and somebody over a ways, the bullet comes up and then back down and reaches a high speed, high terminal velocity, and it has killed people. So that's kind of a sad thing, but yeah, if there wasn't the air resistance, so you make it more aerodynamic, or get rid of the air entirely, then yeah, that gravity will make it go faster, faster, faster as it falls, and it will reach a speed that could kill you. But a penny won't because of the air resistance. Well, again, that is called terminal velocity. It's because of the air resistance. You get rid of the air resistance, and there is no terminal velocity. You would just go faster, faster, faster. So when you go skydiving, terminal velocity is your friend there, right? Because of the air resistance. You're falling, gravity's pulling you down, and you can fall in a couple ways. Sometimes people spread their arms out like that, and they're falling like this, and sometimes they make themselves more like a bullet like this. They make themselves more aerodynamic. You're going to have a different speed that you can reach depending on your shape, a different terminal velocity. When you do this, you increase the air resistance. There's more area for the air to push on you. And so you're going to sort of max out at a lower speed. When you do this, you become more aerodynamic. Now you'll still have a terminal velocity. You'll still have a maximum speed that you can reach, but it's going to be a higher maximum speed because now you're cutting through the air better. And then you do this again and you slow back down to that terminal velocity. And then you do this again and you speed back up to that terminal velocity. And then when you're ready, you pull your parachute. And of course, that creates a lot of air resistance, like a big piece of paper. You've increased the drag, and your terminal velocity is now very low because the air resistance really counteracts the gravity. And so you're able to just float down slowly. So that's what terminal velocity is all about. It's about this balancing of forces between gravity and, in this case, the air or drag force. And you reach a maximum speed. So, thank goodness for that. Keeps a penny from killing you off a building, right? It also allows you to fall with a parachute. If there's no air resistance and you jump out of the airplane, you pull that parachute, it won't even inflate. And even if it did, there'd be nothing to push up on the parachute. You'd fall at the same speed even with a parachute. So thank goodness for that air resistance, counteracting gravity. So the main things you need to get from this, back to the last video, gravity is depending on two things: the mass of the object and the distance between the objects. And then we know that objects will fall at the same speed without air resistance. And that because of air resistance, there is this thing called terminal velocity. All right, I would like you to make sure you write down the thing on terminal velocity. You've now watched this video. Be ready for a quiz coming up next week on gravity stuff. You probably want to rewatch these videos. Make sure you have the stuff in your notes. And then I've also put up a couple of YouTube videos today in addition to this. You're going to watch this and you're going to watch the YouTube videos that I put up as well. And then make sure you answer the questions on those videos. I will have a few quick questions just to make sure you actually watched, and just return those to me as well, due by Friday. As always, there will be a Zoom meeting today at 10 o'clock if you'd like to see me there, and I will look forward to talking to you guys again next week.